Hey guys, Buildzoid here, and today we're going to be taking a look at another DDR4 overclock, because I realized that I've not actually done this yet. Like, I haven't run any, I've not done a video about running Hynix DJR on Ryzen, so yeah, here we are. Anyway, the memory that I'm using is 4 8 gig sticks of Gigabyte Aorus RGB memory. This is actually two different kits. One of them is rated for 4800, but the weaker kit is rated for 4400 CL19. They use SK Hynix 8 gigabit, DJR memory chips, and since these are single rank DIMMs, and we have 4 of them, and this is a dual channel platform, this is a dual rank memory setup. Also, thank you to Gigabyte for providing the memory. The motherboard is a Gigabyte B550 Vision D-P, and that isn't from Gigabyte. A fan of the channel donated this board to me like a while ago, and it's been great. It's like the reason I'm using it right now, and also the reason why it looks the way it does, is because it's basically my favorite AM4 motherboard, and I've like used it on LN2, and there's a bunch of mods on it to sort of fill out some of the gaps. Because the thing is, this is meant to be like a creator motherboard from Gigabyte. It's not meant to be an overclocking board, so there was a few things that were missing in terms of the feature set and like design. So yeah, that's why it looks the way it does. Though admittedly, most of the modifications are on the back of the board, not the front. The orange stuff is just Plastidip, which is my preferred method of insulation for LN2 overclocking. And the CPU that I'm using today is my Ryzen 7 3700X. And the reason I'm using the Ryzen 7 3700X today and not the 5950X is because, unfortunately, this board recently suffered a VRM failure, and I repaired it, but I don't really, I'm not 100% certain why the VRM failed, and so I didn't exactly want to, do the initial test runs of the board with the 5950X in it, because VRM failures can have potentially catastrophic consequences for things downstream of the VRM. So, yeah, this is sort of like partially we're taking a look at a Hynix DJR overclock. Partially, I'm also just verifying that the board is now functional again after I've fixed it. I'll make a video about the actual repair, probably right after shooting this video, to be completely honest. Anyway, so that's the setup, dual rank Hynix DJR. As you can see, I have a fan on the memory, and the fan is absolutely necessary. Hynix DJR is very temperature sensitive. I spent so much time trying to stabilize the memory here without the fan on it, and it was really bad. Basically, without the fan, I couldn't even get 3800 CL18 to work. It might be because I was shoving too much voltage into it, but yeah, I was at 18, 22, 21, and I was still getting errors in memory stress tests all the way at 400%, because the thing is, the heat spreaders on these DIMMs are very thick. So when you have 4 of them next to each other like this, there's just no airflow for there's no cooling for the inner 2 memory sticks, because there's just no space around them. And yeah, they just end up running insanely hot, and the stability ends up being atrocious. And even with the fan on, I mean, the fan does a lot for lowering the temperature, because RAM really doesn't produce a lot of heat. So even when you have memory sticks like this, where effectively all of the cooling that's happening right now for this memory setup is basically the top edges of the heat spreaders, because there is no space in between the DIMMs. So I don't think there's any actual airflow between the memory sticks. So the cooling is entirely through the top edge of the DIMMs, but that is still way better than no forced airflow, because yeah, RAM really doesn't produce that much heat, but convection is really, really slow. So yeah, with trying to run these without the fan was just very, very, very painful. And yeah, if you're serious about overclocking a Hynix DJR setup, put a fan on it. Absolutely 110, put a freaking fan on the RAM, because it is so temperature sensitive. And especially if you have 4 DIMMs stuck next to each other like this, it's just an absolute nightmare for cooling. Anyway, so let's take a look at the settings. I'm not particularly proud of them, but like I said, like the main issue here is that, I spent a lot of time trying to get this stable without the fan. So once I figured out that actually the main problem is the temperatures, as soon as I got something to pass that wasn't like atrocious, which this isn't great. I'm not very impressed, but like as soon as I got something to pass, I was like, okay, I'm done with this. Like I don't want to spend any more time on this. Yeah, it's not like yeah. So anyway, as you can see, it has passed 450%, HCI Mem Test Pro. It also passed Test Mem 5 on the on the Anta 77 Absolute preset. And I've also done 22 loops of LinPack, 10 gigs, which takes longer than usually I do 33 loops, but that's on like the 5950X or 12900K, and those CPUs have a lot more cores, and so they run LinPack way, way faster than a 3700X does. So yeah, with 22 loops on 10 gigs with a 3700X takes forever. So yeah, anyway, it passed LinPack, it passed, HCI Mem test, 450%. Like the first, like before the fan, like the point when I decided to finally put a fan on the DIMMs was when I got an error in memtest at 430% or 420%. It was over 400%. Like I was getting all excited, like finally I can shoot the video about this very mediocre memory overclock. And then I come back to the system because it wasn't quite at 400%. And by the time I get back to it, it's at like 415, 20 something. It's over 400%, but there's an error. And that was the moment when I was like, okay, I'm done with this. I'm putting a fan on this RAM because there's no other reason for it to keep erroring. And I was right about that. There really wasn't any other reason. The thing is, these DIMMs unfortunately don't have temperature sensors. So, yeah. And the funny thing about temperature sensors on memory sticks is like, technically speaking, there are memories like you can set up memory overclocks that are stable to like insanely high temperatures. They're just worse than the settings that only work at lower temperatures, right? Like that's kind of the thing. So it's like if you were willing to give up some performance and maybe turn the voltage down, it would be potentially possible to get this memory stable all the way up to like 80 degrees and the fan wouldn't be necessary, but it would also be slower. Nope. I don't know by how large a margin it would be slower by, but it would be slower. Also, if you're setting up your memory like that, RAM doesn't produce a lot of heat, right? So it takes forever for it to get up to operating temperature, right? And that's really, really frustrating. So the fan, like having the fan on the memory also has the benefit that you hit the thermal equilibrium of the memory a lot sooner. Whereas if you don't have a fan, like the heat can build up for like hours because RAM really doesn't produce a lot of heat. It's just also very bad at losing it, right? So it takes a really, really long time to get up to temperature, which is how you get like errors at 400 and freaking 30% in memtest just because you didn't put a fan on the memory. So yeah. Anyway, that's like tips for Hynix DJR tuning, I guess, is just like just put a freaking fan on it. Also, probably don't run 4 memory sticks of Hynix DJR. Or more like get memory sticks that have like heat spreaders that are designed to cooperate with the other memory slots because like you know, I get I guess these might be more aesthetically pleasing, but from a thermal perspective, these are a disaster. Like the DIMMs are very, very thick, and that's just bad for airflow in between them. Anyway, let's go take a look at the BIOS settings. And will we run IDA? Well, the thing is, there's not really much point in me running IDA on a 3700X because it gets different memory latency from, say, a 5950X. So, yeah. Are you kidding me? Is it not going to retrain right now? Okay, it's just being stupid. There. And we're in the BIOS. So then, the B550 Vision has this beautiful white BIOS. This CPU is the 3700X that I degraded intentionally, so it's at just 4.1 gigahertz, because at any higher clock speed, it will not run LinPack. Admittedly, the air cooler is not helping with that, but yeah, it's bad. It's a very, very bad CPU. Anyway, so memory's up at 3800 megabits per second, FCLK is at 1900. The thing is, like, I degraded the cores on this CPU, and the memory controller on it is actually still decent. Actually, not even decent. It's really good. Out of the 3000 series CPUs that I tested, this is actually the best memory controller I have. So, and I have like a 3950X, this 3700X, and a 3600. And out of those three CPUs, this 3700X has the strongest memory controller. It's just the cores on this thing are absolutely terrible. So, and have always, like, they've always been bad, but now they're even worse. Because I did do that, like, intentional degradation test on this chip at one point in time. Anyway, so, you want to disable your power down. This just helps performance a little bit. And then for memory settings, I have cast latency at 17, 21, TRC DWR at 8, TRP at 21. So, yeah, and the thing is, like, there's a chance that, because right now in terms of voltages, so just ignore the CPU voltage. The CPU is trash. vCore, like SoC's at 1.15 volts. VDD 18 I have at 1.9 volts. This can slightly help with CPU stability and FCLK stability. Actually, especially on 5000 series, this really, this voltage can help FCLK stability quite a bit. On 3000 series, it can kind of help with core clock, but yeah, there's no harm in having it at 1.9 volts. Now, I have the memory at 1.6 volts. Now, this is perfectly safe for DJR to run at. Because like you can get DJR memory kits at 1.6 volt XMPs. And now that I say that, those memory kits have to be like, I wonder how well those memory kits do at like elevated operating temperatures, because 1.6 volts is like, it's kind of a lot of voltage. Anyway, so yeah, just 1.6 volts on the memory. For the load line calibration, I have the SoC load line calibration on turbo. Because the voltage regulation on the SoC, like, I actually measured it, it's basically a straight line. So there's really no reason to have like a bunch of V-droop on the SoC voltage. vCore is on standard because that load line calibration gets the best voltage regulation on this board. Anyway, let's take a look at the actual memory settings. So yeah, I have gear down mode disabled, and right, so actually let's start from the bottom. So I do have gear down mode disabled, and I do have 1T command rate working, as you can see, which for a 4DIMM setup like this, it's just necessary to set the address command setup time to 56. Basically what the setup timings do is they shift the starting point of commands going from the memory controller to the memory sticks, because the thing is, when you're sending, so in a daisy chain topology, there's a slight timing difference between when a signal reaches the memory stick closer to the memory controller and when it reaches the memory stick at the end of the chain. And if you're just running 2T command rate, this really isn't a big deal, because a 2T command rate means that each command is held for 2 clock cycles, and that gives you a really big window in which the memory stick can reliably register a command. However, if you're trying to push 1T, each command only lasts a single clock cycle. And so it's really important that those, like, it's now a lot more important that the command arrives at the memory stick within the like time window that the memory stick can actually register the command. And so the CAD bus setup timings allow you to basically shift the starting point of commands so that you get the command aligned with the clock signal correctly so that the memory stick can reliably register it. And basically for these 4DIMM gigabyte motherboards, a address command setup of 56 works really well. I did not come up with the value of 56 myself. This was recommended to me by somebody on a live stream. But yeah, that's like what the setup timings do. If you're wondering how to like figure out what the optimal setup timing is, I'm pretty sure you just have to trial and error it. Because the only way I can think of that you could actually observe what this is doing is with an oscilloscope. And a very, very, very expensive one at that. As DDR command signals are very, very fast. Right? Like each command is only held for a single clock cycle, and a single clock cycle at DDR4 3800 is 1 second divided by like 1.9 gigahertz, which, yeah, it's a very, very, very small amount of time. So, or well, I should be saying just like 1 second divided by 1.9 billion, which is a very small amount of time. And this allows you to basically adjust that, like, command, like, yeah, when that occurs so that it lines up correctly for all of the memory sticks. Anyway, then other than that, I also have the command drive strength set to 20 ohms. This is just a general adjustment that you can do to help with 1T command rate stability on most motherboards. Arguably, this timing should be motherboard specific. Like, there might be some difference between various motherboard manufacturers' daisy chain topologies in terms of what exactly they like for the command setup timing. Anyway, for the command drive strength, setting that to 20 ohms can help with 1T on basically any motherboard in my experience. So that really doesn't seem to be very board specific. Anyway, so yeah, 1T. Also, this is a Gigabyte 6-layer daisy, like this is the good Gigabyte 6-layer daisy chain topology, and so the optimal proc ODT is 40 ohms. On other motherboards, there are other proc ODT values that are ideal. For Gigabyte boards like this one, 40 ohms is ideal. There are other proc ODT values that'll kind of work, but 40 ohms is where the board works best. So, and this is especially noticeable the like more you're pushing the limits of the memory. So, yeah. Anyway, now let's go to the primary timing. So, since I have gear down mode disabled, we can run, odd cast latency, which is why the cast latency is at 17. Now, I am shoving 1.6 volts into the memory, and so it might be possible to stabilize 16. But like I mentioned at the start of the video, I spent so much time trying to stabilize this stuff without a fan that, quite frankly, I'm happy that CL17 works. And the difference in performance between CL16 and 17 is not noticeable. And I can't be bothered to spend any more time stress testing this memory for a 1-tick timing improvement. So I am not doing that. But if you are tuning your own DJR setup, that might be worth trying. TR-CDRD is at 21. It might do 20. It won't do 19. I'm pretty sure 19 won't even post. TR-CDWR is at 8. You should be able to set this to 8 on pretty much any Ryzen CPU. This is actually a really cool like memory controller hack on AMD's part that like this is possible. I might make a video about why this is possible. Anyway, TRP's at 21. I did experiment with lower values of TRP. They tend to cause instability. Now, it is possible that now that the fan is on the memory, it would be stable, but yeah, I haven't bothered to test, and I have no interest in testing. It wouldn't, like, it won't do 18, I can tell you that already, and so it might come down like a tick or two, but it's not going to be some mind-blowing performance increase if I minimize the TRP timing. Now, TRAS is all the way down at 21. It literally can't go any lower because TRAS is a timing that prevents the memory from trying to do something too quickly. And because the other timings are so incredibly loose, TRAS in this memory setup really doesn't do much of anything. So it's at 21 so that you can just basically ignore it the way I have it configured. Now, if you set it higher, it would potentially lower the performance, but yeah, I just have it set to 21 because it doesn't affect the stability or performance of the current memory configuration because of how the TRAS timing works. Anyway, TRC's at 58. It does not go lower, to my great disappointment, because TRC is actually quite important for overall performance. But yeah, lowering it much more than this causes instability. So, as in, like, if you lower it a bit more, this stuff won't even post. So, that's fun. TWR is at 10 and can't go any lower. TCWL is at 16. So the thing with TCWL is, if you have a really big gap between your cast latency and your TCWL timing, your TRDWR timing is going to get looser. And between the two, TRDWR is arguably more important because it controls read to write command delays, whereas cast write latency literally only controls the delay between a write command and the data actually being sent to the memory chip. So, like, you're potentially going to be running into the RDWR timing a lot more frequently than the cast write latency timing. So it's best to have your cast write latency timing relatively close to your cast latency timing on Ryzen CPUs. Yeah, like it could go way lower, but it would loosen out other timings. So that's why it's up at 16. TRDS and L are at 4.4. These don't go any lower than that. WTRS and WTRL are at 4.8. These might go lower, but man, I don't want to spend any more time stress testing this stuff. TRFC's at 450. I'm not entirely certain that it wouldn't do like 444, but it definitely doesn't do 420 because I tried that and it won't even post. Anyway, TRTP is at 6. I didn't bother testing if 5 works, but 5 and 6 are basically the same thing. TFall is at 16. It doesn't go in... Well, I mean, technically you can set it lower, but functionally that doesn't do anything to your performance. So it's better to just leave it at 16. Then same dim timing, different dim timing is at 4.4. These don't go any lower than that. SCL at 2. And then we have the write timings, which are 6, 6, and 2 for the SCL. And these don't go any lower either. And this is sort of like typical dual rank memory setups on Ryzen is if you're running 4 DIMMs or dual rank DIMMs. Well, if you're running 4 single rank DIMMs or dual rank DIMMs or even 4 dual rank DIMMs, like this is kind of what you're aiming for with your tertiaries is you want your 4.4 on the read-to-read different DIM, same DIM timings, and then 6.6 on the write-to-write same DIM and different DIM timings, because they don't go any lower than that in my experience. At least not if you're pushing the memory clock reasonably high. If you're at low clocks, you can sometimes run, I think like 4.4 and 5.5 can sometimes work at low clock speeds, but yeah, it's not worth, like that's not worth doing. In terms of performance. Anyway, SCL is at 2, and TCKE at 1. And that's kind of it. There's really not that many memory timings. So, yeah. Unfortunately, Hynix DJR, I mean, TRFC is pretty good, right? Like, it's better than what you will get out of basically any Micron memory chip. It's better than what you'll get out of a lot of obviously there's like Nanya B-Die, Samsung B-Die, 4 gigabit memory chips, and those all do way lower TRFC. But out of a lot of the more modern memory chips, 450 TRFC is actually, it's quite low. Most modern memory chips don't do TRFCs that low. But at the same time, TRC is... Well, to be fair, Micron TRC is almost as bad. And in terms of primary timings, it is worse than Micron. There are quite a few Micron memory sticks out there that'll do 16-20-20 or 16-18-18 at 3800. I mean, there's also some DIMMs that'll do 16-21. There's quite a bit of variance in terms of the TRC DRD capabilities for Micron memory sticks. But yeah, this is not great. Also, those Micron's DIMMs will do those settings at 1.5 volts. They don't need 1.6. But, yeah, so Hynix DJR is I mean, you get decent TRFC. Most of the other timings are kind of in line with what you'd expect, right? Like, the TRRDs are fine. TCWL is fine. TWR is, TWR literally couldn't be better. SCLs are as good as it gets. Tertiaries are as good as it gets. RTP is good. TFall's good. TRFC's this is technically speaking, as far as 8 gigabit memory chips are concerned, Samsung B-Die is kind of an anomaly in terms of how low the TRFC goes, but Even then, it's like you get okay TRFC or better TRFC, right? It's not the best TRFC, but it's a decent TRFC. So yeah, basically the main issue with DJR is just the primary timings suck. That's kind of it. There's really nothing you can do about it. Uh, or at least there's nothing I've found that I can do about it, especially not in a dual rank setup like this. But hey, it does run 1T command rate, so that's nice. That compensates a bit for the fact that the primaries are so bad, but yeah, that's Hynix DJR. It's very temperature sensitive. It's loose on the primaries. The subtimings are kind of like the subtimings are fine actually, right? I mean, yeah, I wish TRFC was lower. I wish TRC was lower, but that's kind of it, right? Like the rest of the subtimings are like, well, I mean, 444 8. Like this doesn't really get much better than this. Yeah, I think basically the best thing you can do is like 4 4 and then 3 6. Actually, I'm not even sure I've ever seen a 3 6. 3 7 is a thing for some memory chips. And it might even work on this. I just didn't test that because I spent so much time with the memory getting entirely too hot. And I've lost my patience for it at this point. So yeah, the main issue with Hynix DJR is like a lot of it, like Hynix DJR is commonly found in like very high spec memory kits, right? Like, so like if you look at the kits that I'm using here, we have this kit, right, which is 4400. And I have the camera on manual focus, so yeah, but that's a 4400 kit. And then the other kit that I have it on is a 4800 kit. Right, and then all my other, and I have other DJR memory kits in my collection, but those are all rated at like 5,000. And the thing with these like super high clock DJR memory kits is that they're really, really, really expensive. And because DJR does miserable primary timings, and that's the nicest way to put it, the performance just like doesn't live up to the price. Okay, like these memory chips are found on some incredibly expensive memory kits, and they just don't deliver the performance. Like, at all. They just don't. Like, I've not, even on Intel, which is sort of where, like, DJR really, the thing is, like, some people would say that DJR in Gear 2 on Intel shines because you can hit, like, crazy high memory speeds, like 5333 and 5400, 5600, and I, see, that's great and all, except I have Micron kits that hit those same speeds at lower primary timings with similar subtimings, and on Intel, like on Ryzen, we don't have a refresh interval timing, right? So on Ryzen, the TRFC timing is like excessively important. Because if we go here, yeah, like so TRFC on Ryzen is actually like excessively important to overall performance because there's no way to delay the memory refreshes. On Intel CPUs, you can just set your TREFI to like 60,000 or something, and the memory ends up refreshing so infrequently that the fact that the refresh cycle takes 600 cycles or 450 cycles really doesn't make much of a difference anymore, right? And so that's kind of the thing with Hynix DJR is like on Ryzen actually in some ways it's less miserable than it is on Intel because on Intel you can just blow the refresh interval out the window and then it's like, hey, we don't need to worry about the fact that there's like, you know, every 60,000 cycles we spend 100 or 200 cycles more time on like refreshing the memories. Like it's not really that big a deal. Right? Whereas on Ryzen, you're doing that refresh, I think, every 14,000 cycles. So it's, you know, here the impact of the TRFC timing is a bit more significant because there's just no way around, like no getting around it. But, yeah. So like if you get Hynix DJR in a cheap memory kit, it's great. Like it's good, right? Like as a budget memory option, this would be good. The issue is commonly Hynix DJR is found in like high-speed kits that are very expensive. And in those scenarios, it's terrible because it's not fast. It just isn't. Like Hynix DJR, in my opinion, and even the Micron memory chips are like fall into this of like they're basically the like bulldozer architecture of memory chips, where it's like, yeah, the clocks are really high and nothing gets done. It's not quite that bad, but yeah, like I wouldn't pay extra to get Hynix DJR. Um, yeah, like basically, if you're paying more than like $50 a stick, actually $50 a stick of Hynix DJR is already, in my opinion, kind of too much. I wouldn't pay more than $40 a stick of Hynix DJR if we're talking 8 gig sticks. So, yeah. Anyway, that's some Hynix DJR overclocking, and oh man, the video ended up being 30 minutes long. Oh well. Yeah, so thank you for watching. Thank you, Gigabyte, for the memory sticks. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below if you'd like to support what I do here with actually hardcore overclocking. I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store, as well as I have a Bandcamp. So yeah, where there's like horrible industrial noise type music stuff. Yeah. If you'd like to support the channel, there's links for all of that down in the description below. And that's it for the video, so thanks for watching, and goodbye.